Hello students. Welcome to the session, guys. As a few students have asked about these questions, I'm explaining this as well. Try to go through briefly. Level 2 exercise 1. Level 2 exercise 1. Question number 29. Level 2 exercise 1. Yes. Level 2 exercise 1. Question number 29. Question number 29. The question is, let me read the question once. The metallic bob of a simple pendulum has the relative density ρ. The time period of this pendulum is t. If the metallic bob is immersed in water, then the new time period is. Yeah, so to understand that, this we have to consider that if a simple pendulum is in equilibrium state, the weight acting on this is mg down. So net force on the block is, we're not talking about this equilibrium condition of tension in the string and all. On the here on the mass, you can consider this is net force acting on the block is mg down, and band force upwards, that is the net force. So here it is equal to mg into band force can be taken as band force. You have to remember that band force is equal to density of liquid into volume of the object immersed inside the liquid. If it is completely immersed, it's the total volume of the object or a solid body into g. This v can also be expressed as, here if you see, m is because density is equal to mass by volume. So density of, so if you consider solid part, what is that, volume of the immersed part of the solid. If you want, the mass of the solid by volume of the solid is equal to the density of the solid we get. So from this, volume of the solid can be taken as mass of the solid object by density of the solid, m by rho s. So if you replace this, we get rho l into m by density of solid into g. So we can also write it as density of liquid by density of solid into mg is band force. So if you mention here, this is mg into rho l by rho s, and mg is common here. If you take it out, then we'll get 1 minus rho l by rho s. Right? But here it is given that relative density. It is given in the question that relative density means density of solid by density of liquid. Density of solid by density of liquid is rho. So if you here density of liquid by solid, so if you bring it here, then you can write density of solid by density of liquid here. So you can rewrite this as mg into 1 minus 1 by rho. Okay. Then as net force is mass times effective acceleration, you can write it by mentioning this and cancelling m, we'll get effective acceleration is equal to g into rho minus 1 by rho. 1 minus 1 by rho is rho minus 1 by rho. So if this is the effective acceleration, in this condition, where this is the effective acceleration of this bob when it is immersed in the liquid here. So under that condition, what will be the time period you are asked to find? And actually, in terms of the time period of the block when it is in air. So time period in this liquid can be expressed as 2.√L by A effective, whereas in air is 2.2 by 3. So if you take the ratio of these two, A effective or G effective, anything you can take here. So it will be T dash by T, as M is the same. Okay. So as it is depending on the acceleration part, you can say t is directly inversely proportional to root of g. So it is t dash by t. T in the liquid by T in A is equal to square root of G in A by G in liquid. So it is equal to G by G into rho minus 1, G into rho minus 1 by rho. So on simplifying this further, you'll get T dash is equal to T into rho by rho minus 1. So, so 29th one, if you see the option T into square root of rho by rho minus 1. Option 4 is the right one. And another one, you see the question number 30 as well, similar to this. Let me read the question once. Let me read the question once. A simple pendulum with a brass bob has a period T. The bob is now immersed in a non-viscous liquid and oscillated. If the density of the liquid is 1 by 8 of brass, the time period of the same pendulum will be. The time period of same pendulum will be. If you look here, so when the pendulum is in air, time period can be expressed as t equal to 2.2 del by g. Again, if this if pendulum is having a brass bob, a bob is made of brass, and if it is immersed in a liquid, the bob is immersed in a non-viscous liquid and oscillated, and it is given the density where the density of the liquid is density of solid by 8, 1 by 8 times the density of solid, density of the brass means density of the solid, and time period of the pendulum here will be. So to understand that, you have to know what is effective acceleration. Okay, so for that, let us try to mention what is net force, and hence we can get net acceleration or effective acceleration. So net force in this is equal to mg minus band force. Just like in the previous case, band force is what, f l into density of liquid into v into g, where v can be expressed as, yeah, in terms of v only are expressing here as well. So density of mass of the bob, here also we are expressing it as density of the solid into v, as density equal to mass of the bob by volume of the bob or solid. So by here, if you observe, as m is v into g, rho is vg, and is rho l vg. Here vg is common. If you take this out, then we can write rho s minus rho l into vg. So this here, as in the question, it is mentioned that density of the liquid is 1 by 8 times the density of the brass bob or the solid. If you substitute this here, you get rho s minus rho s by 8. So here 8 minus 1 7. 7 by 8 into rho s, you will get rho s, right? Density of the solid. Okay, density of the solid into Vg. So F net is equal to 7 by 8 times density of the bob into V into G. Density into volume is mass. So you can write this as 7 by 8 into mg. So if you write for F net force as mass into effective acceleration, then you'll get effective acceleration is 7 by 8 g. So now that if you substitute here, t dash is equal to 2.2 the effective acceleration, it is 7 by 8. 8 goes numerator and becomes 8l by 7g. So, but this you can rewrite it as 2.root L by G into root of 7 by 8 by 7. This root 2.root L by G is the initial time period, that is time period in the air medium. So, you can write it as in terms of that. So, root square root of 8 by 7 into T. So, that will be the correct option. You can go through this once. And question number 31 as well. Some of you have asked for this question as well. So, this question is nice. A pendulum clock is taken 1 kilometer inside the earth from mean sea level. Then the pendulum clock, options are given as, loses 13.5 seconds per day, gains 13.5 seconds per day, loses 7 seconds per day, gains 7 seconds per day, like that the options are given. So how to understand this? So let us consider the time period in general for any particular under SHM is what is that? Pendulum clock in system is 2.2 del by G. So if you take the pendulum into the depth, g will varies. This g will varies with the depth. The change in the g with the depth is given by gd is equal to g into 1 minus d by r, where d is the depth from surface and r is the radius of earth is mentioned as earth, right? So the values you have to remember here. Otherwise it will be given in the question. Here depth is given as 1 kilometer. Radius of earth, you have to remember that it is 6,400 kilometers. Radius of earth should be 6,400 kilometer, and the depth is given as, it is given that the depth is equal to 1 kilometer. It is mentioned, it is given in the question. So if you substitute this, we get g into 1 minus 1 by 6,400, and simplifying this, we will get g at the depth is equal to g into 6399 by 6400. But at that depth, time period can be expressed as 2.2 L by g at depth, gd. Now as you can understand simply that, as here if you see, if you go, this rate increasing means, that means it takes to complete one oscillation, it takes more time. So this you can call it as, there is a losing time. It is losing time. Okay, it is more taking more time, so you can say it is losing time. So how much it is losing, you have to find. For that purpose, if you substitute here this and simplifying this value, we can say 2 pi to root L by g. If this number, if you take separately here, this will give you actually some number, but here how much it is losing comparing with initial value you want to know. So for that purpose, let us take t dash minus t, so is equal to, on both sides if you subtract t, so here also minus t will become, so then you can take this number minus 1 into t, and simplifying this you will get approximately 6.7 or 6.8 seconds, 6 point, so approximately you can take it as 7 seconds. 7 seconds. That means the clock loses 7 seconds. That's what you can conclude. So the clock said to be losing 7 seconds approximately. So that is how we can conclude it. So it gains or loses. How much? 7 seconds per day. How we are considering this amount of time is, when t is in comparing with the day, how much time it takes in a day. If you take in a day, the time taken by the pendulum clock is nothing but 24 into 60 minutes, 24 hours into 60 minutes into 60 seconds. So by taking that into consideration, we get this much time. What is this? Seconds. 673,920 into 10 power minus 5. So that gives approximately 6.7 or 7 seconds. So this is the time losing by the clock in one day. In